let's look at the question I'm having here. I'm given integral of x squared sine x raised to power 3 dx, and I'm having integral of sine x cos x dx. Then I'm having integral of sine 6x dx, and also integral of sine, that's actually x squared exponential x raised to power 3 dx. Then I'm having Jagaban here, exponential x raised to power 3 plus 3 sine into bracket x raised to power 3 plus 2 x raised to power 10 dx. Now, actually, looking at all this integral question, there's a general method I can use to solve it. That's my substitution method, because everything here is just what I can just use substitution method to do, just solve it. I'm going to get the answer. Now let's look at the first problem. Probably I'm not going to solve all the questions in this video. This I'm going to solve it in a separate video. This particular question, I'll solve it in a separate video so that you have the better knowledge of how to solve it. Now let's say I'm having that's integral of x squared sine s cube dx, right? So, and I'm asked to integrate this kind of question. At first, I can actually apply integration by parts, and it's going to work. Yes, it's going to work, because I'm having two functions here. I'm having the algebraic function and also the trigonometric function. But the better way to solve it is to just use my u-substitution method, so that I can just say let u equals what? That's x raised to power 3, right? Then if my u equals to x raised to power 3, I can just find the u dx. Find the u dx, I'm going to have the u equals to what? 3s squared dx. That means I'm differentiating this. If you don't have the knowledge of differentiation, kindly pause this video and go and watch my previous video on how to general knowledge on differentiation. Now looking at this, I can just go ahead and make my dx the solid of the formula, so that I'm going to have, let me just say the solid of the relation. I'm going to have the x equals to what? The u by what? 3s squared. Then let me just go back to my question. Looking at this, I'm going to have integral of x squared, right? Then sine. Instead of me to write s raised to power 3, I'm going to write what? U, because my s raised to power 3 equals to what? U. I'm going to have sine u multiplied by my dx, which is equal to what? Du over 3s squared. If you check it very well, this is just it. So looking at this, I can just cancel this out, right? So that everything is going to be integral of sine u multiplied by what? That's du over 3. Now, according to the basic rule of integral calculus, whenever I have a constant, I can actually factorize it out, so that I'm going to have this to be 1 over 3 integral of sine u du, right? So it's very simple. So looking at this, and I know that whenever I integrate sine u or sine x, whenever I'm asked to integrate sine x dx, integrating sine x dx will actually give me what? That's negative cos what? Cos x plus c. So looking at this, integrating this, I'm going to have minus 1 over 3. My this is going to be what? That's cos what? Cos u plus c, right? So am I going to stop right here? No, it's not possible, because my u is actually a function, right? So we can just recall that your u equals to what? That's x raised to power 3. Show that everything is going to be minus 9 over 3 cos s raised to power 3 plus c. That's just the answer to the first question. Now let's move to the second question. I'm having integral of that's sine x cos x dx. So this is actually a trigonometric function. Is this trigonometric function? Yeah, it's sine x cos x, but I'm going to use substitution method to solve it. So using substitution method, I can actually call my u, I can say let my u to be equals to cos x or what? Or sine x, because whenever I differentiate cos sine x, I'm going to have cos x. And whenever I differentiate cos x, I'm going to have negative sine x. So I can just say let my u to be equals to what? Let me just take it as cos x, right? Show that in this case, differentiating cos x, I'm going to have du dx equals to, that's du equals to minus sine x dx. Whenever I differentiate my cos x, I'm going to have negative sine x, and whenever I integrate my cos x, I'm going to have sine x. But if I should integrate my cos x, I'm going to have if I say integrate my sine x, I'm going to have negative cos x, just like the case of this. So let's just go ahead and just solve it. I'm going to have, I'll have this to be my dx equals what? Du divided by negative sine what? Sine x. Sure, you get now. So let's just put it back. I'm going to have integral of sine x. Can you see this? Multiply by what was my cos x after just making it have, when after substituting this as what, as my u. My cos x in this case is going to be u multiplied by the x is what? That's the u over negative sine what? Sine x. That's very good. So in this case, my sine x will cancel this, right? So the thing is that my negative sign is actually what? A constant. Then I can just bring it out. I'm bringing it out. I'm going to have minus integral of u du, right? And whenever I integrate u, it's just like I'm going to have it to be u raised to power 1 plus 1 divided by what? 1 plus 1 plus c, right? So here I'm going to have u squared over 2 plus c. But don't forget the negative sign, you put it there, right? So you can just recall your u is something. Yeah, it's something. Your u is equals to cos x. So you are going to have negative cos square x divided by 2 plus c. That's just the answer to the second question. So let's check the third question here. The third question that we are having here is actually integral of sine 6x dx. This is actually simple, right? So to differentiate, okay, to integrate this shouldn't be the problem. Just say let's my u to be equals to 6x. So if I just take my u to be 6x, no, differentiating this, I'm going to have my 6 dx, right? So let me just make my dx set of, I'm going to have my dx to be equals to du by 6. Putting everything, I'm going to have integral of sine 6x is u multiplied by my dx, which is what? Du by 6. Factorize 1 over 6 out, I'm going to have 1 over 6 integral of sine u du, right? So let's go ahead and integrate. Integrating sine u, I think that's negative cos u, right? I'm going to have minus 1 over 6 cos what? Cos u. The negative sign that I'm going to get whenever I integrate my sine x is this plus c, right? So recall, your u is something, your u is actually, that's my 6x. Then I'm going to have minus 1 over 6 cos 6x plus c. So I think that's that under the first, second, and third question. Now let's move to the fourth question, which is the last question I'm going to solve here. This I'm going to solve it in a separate video, right? Which I'm going to drop tonight. Now let's just go ahead and just integrate this. I'm having question 4, right? To be integral of s squared exponential x is power 3 dx. Actually, looking at this question, I can actually apply my by parts because I'm having two different functions here. But solution method will be the best. If I just say let my u equals to, that's x is power 3, right? You're taking the power of this as your u. Because whenever if you take this, it's not making sense. You can just say, okay, your du dx is going to give you 2x, and it's not going to cancel this out. So let's just differentiate this. I'm going to have du to be equals to, that's 3x square, right? Dx. Then go ahead and make your dx set of formula, right? So you're going to have your dx to be equals to what? That's actually du divided by 3s squared. And come back to the question. You're going to have integral of s squared exponential u, because your x is power 3 is u, have dx. So yeah, my dx is something, I'm going to have integral of s squared exponential u multiplied by dx, which is what? Du divided by what? 3s squared. So here, if you see this is going to cancel this out, then I can just factorize my 1 over 3 outside, right? Integral of what? Exponential u du. And you can recall, whenever I have integral of exponential u, is actually, if I should integrate exponential u, is still the same thing as exponential u, right? And likewise, if I should differentiate exponential u, it's still the same thing as exponential u. But if I'm given, let's say, exponential a raised by x, and I'm asked to differentiate it, I'm going to have a exponential what? A raised by x, since yeah, something like that. But if I'm asked to integrate exponential a raised by x, that's what? Exponential a raised by x over a, abi? I think that's 1 over a exponential a, exactly. Don't worry, we soon get there. I'm going to break down everything for you guys. So now, looking at this, integrating this, I'm going to have 1 over 3 exponential u plus c, right? So I'm having 1 over 3 exponential. What's your u? Your u is what? S is power 3 plus what? Plus c. And most of you don't know the reason why we are adding plus c. I think I've mentioned the reason why in my last video. The reason why is actually whenever you are integrating without a limit, that is, you don't have anything upper limit, let's say a here, b here, you don't have anything like this, you can just put your c, where your c represent the arbitrary constant of function f of x, or function any function. You understand it down. So I think this is the answer, right? So let's just wait for the solution to this. I'm going to drop it along with this video, so it's going to be separate. It's going to be in a separate video. If this is your first time visiting my channel, please kindly click on the subscription button. Just hit it and make sure you drop your question in the comment section below. I'll be there for you, and I'm going to solve every question. Any question you just drop, I'll solve it for you. So thanks for watching.